Good morning, all of you. Okay, in this chapter 11, force and pressure, we have studied further that how the force is being described as a push or a pull simply. After it, we have discussed some more topics in force that forces are due to an interaction. Next one was exploring forces that how the force is being add in when the force is being applied in the same direction, and what about what if the force is different between the two forces, what if the forces are being applied in opposite direction. Okay, so next one was a force can change the state of motion. We have already discussed more and more example of cricket and carom in this topic. After it, next one was force can change the shape of an object. Okay, we have discussed this thing also by the taking the example of dough and smiley or emojis. Okay, emoji not emoji only smiley, smiley ball. This is the observation we have already taken from this while studying this topic force. Next one was type of force that contact force and non-contact force. Okay, in which in contact force we have studied this example and these types. That first of all it's muscular force with this example. The second one that is frictional force. Okay, that how the object in moving object in motion or in running condition becomes to the rest position. Okay, it's the only reason of frictional force. This after it, this is a non-contact force. Okay, we already discussed many examples for it. Okay, for non-contact type of force, and one of that is magnetic force. Okay, okay. And next one was electrostatic force. We have discussed with the example of a balloon, okay, and a straw also. That how the electrostatic force is being applied. Next one was the gravitational force, okay, the Newton Baba story of Newton Baba and all. And pressure, we have already discussed pressure in last lecture. That what is pressure? It is the simply force upon unit force per unit area. Okay, on which the force is being act simply. We have discussed that the SI unit of pressure is Pascal. Next one was pressure exerted by the liquid and gases. We already studied this, discussed this activity 11.8, 11.9, and 11.10. Okay, 11 point activity 11.10 was the was for the pressure exerted by the liquids and gases. But this is the last activity which was showing that liquid exerts equal pressure at the same depth. Okay, after it, next one was the we have taken the example of this puncture. Okay, you must might have observed these things. So it simply shows that the pressure exerts on uh, air exerts pressure on the inner walls of an inflated balloon or a tube. Okay, so it's simple. Next one is the topic we are going to study today is simply atmospheric pressure. So what is it actually? So in previous lectures we have already discussed, we already studied that liquid exerts pressure on the walls. Okay, gases also exerts pressure on the wall. So we can simply say that air is also a gas. Okay, the envelope of the air around us is known as the atmosphere. Okay, you already studied this thing uh, in previous standards that the envelope of the air. Okay, जो एक गिफ्ट है ये अर्थ है जो गिफ्ट है एक एनवेलोप में पैक करके दिया है तो एनवेलोप क्या है हमारा एटमॉस्फेयर द एनवेलोप ऑफ द एयर अराउंड अस इज नोन एज द एटमॉस्फेयर इट्स वेरी सिंपल. Next one is the atmospheric air extends up to many kilometers. Okay, many kilometers above the surface of the earth. Okay, we already know that the atmosphere is not about only 2 to 3 kilometers, but the atmospheric air extends up to many kilometers above the surface of the earth, and the pressure exerted by the air around us. Okay, the pressure exerted by the air around us is known as the atmospheric pressure. Okay, now how we can simply calculate or we can explain further this atmospheric pressure that take an tube. Okay, tube of unit area, tube of its base unit area. Okay, so in which the if air some air is being filled up with some air. Okay, then what is the force of this tube? Gravitational force. It's obviously it's the force of this air. It's m into g. Okay, so which is being applied on the unit area, so it's simply the force of this tube is atmospheric pressure. Okay, which is the shown in figure. So atmospheric pressure is the force of gravity on air in a column of unit area. Okay, tube of unit area. Next one is pressure of atmospheric on your atmosphere on your head. Okay, so yeah, this activity is already given in your book. Okay, you are given in your textbook. So uh, understand this by calculating the example you are given. Okay, they are telling that if your head is let's taken as 15 centimeter by 15 centimeter. Okay, you can just take it by the 15 centimeter radius also, or 10 centimeter radius. Okay, but calculate some examples with this. Next one is, okay, so this was the atmospheric pressure. Okay, what is the atmospheric pressure and how it is being created? Now already we have completed all the topics from this chapter. So what the topics we have discussed is, first of all, atmospheric pressure. Okay, right now we have discussed the what is atmospheric pressure is. Afraid pressure. Okay, we have yesterday in last lecture we have discussed the pressure. In before the last lecture we have studied contact forces, electroforces, electrostatic forces, force, friction, gravitational forces. Okay, gravitational force, gravity, magnetic force, muscular force, and in non-contact forces also. Okay, and pull and push. Okay, force is a pull and push. Pressure you are given two times. Okay, it's by mistake. And these are some important topics we have to discuss further. So what you learned, matlab, these are the main topics we have learned something new in this chapter. So first of all, force could be a push or pull. Okay, we already discussed in this chapter also that force can be described as a push or pull. Okay, we are starting, we have seen is you've seen it in the starting. Next one is a force arises due to the interaction between two objects. It's simply if you are standing behind something, and then the object some behind an object, and it will not come in the motion until and unless you are applying some force on it. Okay. Next one is force as magnitude as well. Force as magnitude as well as direction. Okay. It's simple. A change in the speed of an object or the direction of its motion, or both implies a change in its state of motion. Okay, we already discussed that what is state of motion, what is zero state of motion. Okay, so a change in its in the speed of an object or in the direction of its motion. Okay, of the direction of the motion of the object, or both implies a change in its state of motion. Okay, it's simply a force acting on an object may cause a change in its state of motion or a change in its shape. Okay, we have taken this example of dough or smiley ball for this point. A force can act on an object with or without being in contact with it. Okay, so it was non-contact forces. Next one is force per unit area is called pressure. It's simply a definition of the pressure. It is force per unit area is called pressure. Okay, area on which the force is being acts simply. Liquid and gases exert pressure on the walls of their containers. We already discussed it with this activity 11.8 to activity 11.10. Okay, and we have taken the example of puncture tube, your tube of the cycles. Okay, during the puncture for this liquid exerting pressure on this gas. Gas is exerting pressure on the walls. And the next one and last one is the pressure exerted by the air around us is known as atmospheric pressure, which is definition of this atmospheric pressure. Okay, so this was the our chapter, maybe 11, forces, force and pressure. So thank you. You all are supposed to write something, write everything of this is in the fair note, okay? And I will provide you some material as soon as possible, okay? And you are obviously you are going to do some good work in it. And I will ask you to show it to me also as soon as possible. So, okay, thank you very much.